Welcome to this tutorial on loading arrays with np.load. In this video, you'll learn how to efficiently read and load NumPy arrays from binary files back into memory. This is an essential skill for working with saved data in NumPy and will help you manage your data workflows more effectively. np.load is a NumPy function that reads and loads arrays from .npy or .npz binary files back into memory. These binary files are NumPy's native format for storing array data efficiently. When you save an array using np.save, you can later retrieve it using np.load, making it perfect for data persistence and sharing datasets between different projects or sessions. The basic syntax for loading an array is straightforward. You simply assign the result of np.load to a variable and pass the file name as a string argument. The file name should include the .npy extension. For example, array equals np.load, then in quotes, filename.npy. This single line of code reads the entire array from disk and loads it into memory. Let's walk through a complete example. First, you import NumPy as np, then you can save an array to a file using np.save. For instance, we create a two-dimensional array with values 1, 2, 3, 4 and save it to data.npy to load it back. You use np.load with the file name data.npy, storing the result in loaded_array. Finally, printing loaded_array shows you the exact same data that was saved. The np.load function has several important parameters. The first parameter is file, which specifies the path to the .npy or .npz file you want to load. The second key parameter is allow_pickle, which controls whether the function allows loading pickled objects. By default, this is set to false for security reasons, as pickled objects can potentially execute arbitrary code when loaded. Once you've loaded an array using np.load, you can work with it just like any other NumPy array. You can access properties like shape and dtype to inspect the array's dimensions and data type. You can perform mathematical operations, such as multiplying the array by 2. You can also apply NumPy functions and use array indexing. The loaded array behaves identically to an array created directly in your code. There are several common scenarios where np.load is particularly useful. First, loading previously saved training data allows you to work with large datasets without recreating them each time. Second, resuming interrupted computations becomes easy since you can save your progress and load it later. Third, sharing datasets between projects is simplified because .npy files are portable and preserve all array metadata, including shape and data type. Let's recap what you've learned. np.load reads arrays from .npy files efficiently and reliably. Loaded arrays work exactly like any NumPy array, supporting all operations and functions. This function is essential for efficient data persistence, allowing you to save computational results and reload them whenever needed. With np.load, you can manage your data workflows professionally and avoid redundant calculations.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.